already 2:02. So, good morning, everybody. Good afternoon, good evening, having people worldwide connected. And today, it's really a pleasure for me to be here with you all, with possibility to manage one of the most topic trend, so how we can scale wet chemistry testing for high throughput labs. It means how we can help labs to automate and streamline the workflow needed to cover daily routine activities in high throughput labs. So first of all, this session is let's do the engagement of this webinar. So this session is recorded, and the recorded will be forwarded by email. Duration of this webinar is around 40 minutes as a speech session. Then we have at the end one Q&A session. Concerning Q&A, please use the Q&A area we have here on Zoom to send all the questions that will be handed at the end of the speech. And the speaker, so myself, Claudio Strino, I'm the product manager at KPM Analytics, in this case MS, the wet chemistry branch of KPM Analytics. And today we want to show you and speak with you about the main challenges and pain points that labs need to manage daily based. And we will see how we can help those labs in improving the efficiency of the lab, not only concerning the instrumental side, but also the raw materials and the human resources involved in the analytical process. Because daily based, the main challenges are the analytical complexity, because we know that increasing number of samples, number of matrices, a lot of time complex matrices, and the number of analytes that we need to analyze. So costly instruments and that need to be maintained, calibrated, and QC and QA pushing for reliable results. Of course, we have also to maintain and follow all regulatory pressures, because we need to be compliant with the regulation body, and maintaining the full data traceability, which is a must to be fully accredited. We daily based lab need to manage cost and efficiency. So the full lab is involved from top management to the operators, because concerning the turnaround expectation that are very quick, expensive maintenance and consumables for all the instruments involved in the analytical process, and of course, limited resources for automation. And the biggest problem is the last but not the least is the recruit and retain trained analysts, and of course, for those analysts in the lab, keep them trained and help them in, let me say, growing. What is the ideal tool we could use to cover large volumes labs? So the instrument, the tool should be versatile and be able to adapt himself. It means analyze multiple analytes in various matrices, be able to follow and have an easy fit in the lab workflow and SOP, that all the tests are in compliance with the main regulations. For example, ISO, EPA, that the tool is fully automated. So it means fully integrated with LIMS, long walk away time with minimum human intervention, fully automated startup, shutdown, calibration, QC, and sample test. The tool should be able to cover the high throughput, so complete large volume in time. Of course, a low cost of ownership means should have minimum waste generation and minimum consumable usage. And moreover, that the tool is easy to use. So considering those two parts, so what are the main challenges managed by the labs and what should be in the ideal analytical tool, let's see how we can fit those two concepts. So today, one of the most trending topic is the lab consolidation process, where with lab consolidation, we know the labs need not only to optimize, as we say, the instrumentational side, but also human resources and raw materials involved in the process. What does it mean? That we can consolidate, in this case, on our SmartChem platform, different techniques. And it means that we cannot replace at all the other techniques, but we can really reduce the workload on those other techniques. And moreover, we can preserve those different techniques. One typical example is ion chromatography, because of course, sensitivity of ion chromatography is not the same of the discrete analyzers, of course. And this is the main reason why we cannot replace at all other techniques. But considering, for example, wastewater testing, all of us knows that ion chromatography are really, really impacted by those dirty matrices concerning the detector, the column, and moving those samples on discrete analyzer, we can preserve other instrumentation. Moreover, we can also run all our samples on a discrete analyzer and only perform a further investigation for those that are below the sensitivity of the discrete for a further investigation. And it means that only a small percentage of our sample need to be analyzed with other technique to have more in-depth investigation on the sample. This is very important because considering the high throughput, SmartChem offer with having on board multiple cuvettes parallel testing, it means that we can start multiple reactions in parallel. While ion chromatography, it is true that we may have multiple parameters at once, but the average time is around 20 minutes per sample. While, so consider 200 samples to be tested on a SmartChem, in the SmartChem 600, we are shorter than an hour for testing. On the ion chromatography, we need much more time. And moreover, we can also reduce all those stuffs behind each technique, which is the number of service contracts, the attention workload for the operators in working on all those different techniques, the maintenance on all those different instrumentations. And it means that instead of having multiple operators, each one dedicated to a different technique to cover the analytical needs of our samples, by consolidating everything on a single platform, we can drastically reduce the number of operators involved in the process. It means that we can dedicate our resources to more added values for a lab. So our discrete analyzer is based as operating principle on the Beer-Lambert law. So we are measuring the intensity of the light through a chemical reaction, and where the absorbance we will detect is in relationship with the concentration of the solution. Typical question is, what are the parameters, what are the matrices that we can analyze with the discrete analyzer? So as we can see here, there is a huge panel of parameters. This is just an example of the most common methods, but there are other also parameters that can be tested. We can see anion, cations, and non-ionic parameters. And on different matrices. So on water, all kinds of waters, drinking water, seawater, wastewater. Agrochemical testing means soil, sludge, plant, fertilizer extract, foodstuff. And one of the most common usage is the testing of multiple parameters on meat extracts, and also beverages. So we can have ionic and enzymatic testing, for example, on beer, on wine, and also on spirits. MS, the first unit have been introduced in the market in 1992, made in Italy. So the factory is based in Italy. And we have really more than 10,000 units installed on field. Those units are mainly involved in water, wastewater facility for commercial or industrial lab, analyzing water, beverages, as we saw, soils, plant fertilizer, and food extracts. We have 4 models available: SmartChem 200, 210, 450, and 600. And the one that can really fit the need of high throughput labs is the SmartChem 600. Because as we can see here, we have the possibility to load on board up 200 samples in one shot. So SmartChem 600 is really high performance unit with direct reading of in-cuvette reaction with true sample blanking. What does it mean? That the reaction will be read directly in the same cuvette when the reaction has been developed. And true sample blanking means that the sample blank, because we have possibility, we will see, to detect also the sample blank, is performed in the same cuvette where the reaction will be performed. So it means that we will put the sample in the cuvette, we will read the blank of the sample, and then we will perform the addition of all the reagent needed to complete the reaction. Minimal lab requirement for thanks to the long walk-away capability, because we have fully automated workflow, including preparation and run of the calibration, QC, and samples, up to 200 samples on board. We have a refrigerated compartment for reagents, so instrument is able to preserve reagents from on board time. And thanks to built-in barcode for samples and reagents, we can fully automate the process. What does it mean? That we are not anymore prone to any human error also in positioning the liquids on board, because we can place the reagent as we want, we can place the samples as we want, positive recognition with barcode readers, and importing from LIMS the working routine. So everything will be performed without any issue. High throughput because means that we can reach up to 600 tests per hour. Really flexible because in the reagent compartment, we have possibility to load up to 100 reagents. And we can define 600 as low running cost unit because working with very low waste, because managing microliters for sample and reagents, and low consumables because all our SmartChem, all our discrete analyzers are equipped with reusable cuvettes. So as we can see, is intended for very large labs, and typical parameter per sample is unlimited because thanks to 100 positions available, we can really fit an attending number of parameters in the reagent plate. This is an overview of the system where we can see that there are 3 dispensing arms. There is 1 mixing unit for the reactions to mix the solution in the cuvettes. There is the washing station, which is dedicated to wash the cuvettes after the usage. 1 reaction plate where all the cuvettes are hosted. The reagent bay, this is the reagent compartment, and the sample bay. As we can see, the sample compartment have been divided in 2 different compartments. Why? To really guarantee the true sample addition to the ongoing routine, because while the instrument, is working on the first carousel, means that we can load the first set of 100 samples. While the instrument is analyzing the first set of samples, we can proceed adding new samples without interrupt the ongoing analytical routine. So we have highly optimized hardware for throughput, automation, precision, and also thanks to the advanced software Pro, we have also an easy to use platform with high flexibility and automation. One of the most important topic is how we can reduce cost per test. We can reduce cost per test because as we saw before, by consolidating different techniques on the single platform, we are reducing the human resource involved in the analytical process. Moreover, passing from milliliters to microliters for sample and reagents, because manual or semi-auto techniques work in milliliters, while here working microliters, we can save cost before testing because we need to prepare less amount of chemicals for reagent and standard, and after testing because we have less amount of waste generated by the instrument. Thanks to the reusable cuvettes, and we already saw the washing station, the instrument, all the SmartChems are only generating waste, liquid waste, and not the hazardous solid waste, because today we are the only brand, only company on the market working with reusable cuvettes. This is an hardware overview where we can see, as we say, that we have 2 samples carousels. We can load on board 200 samples because we have 20 removable racks with the possibility to host 10 samples each. Urgent sample loading, yes, because on the ongoing routine or when adding new samples to the ongoing routine, we can add at any time urgent samples. And with 5 ml available for each one, we can cover a really huge set of parameters considering that we are working microliter for each test. We have also an overview concerning the reagent bay, because we have possibility to add on board up to 100 position, because on each position we can load 150 ml bottle or 225 ml bottles. We have level sensing, so also inventory management is fully automatic. So for each liquid loaded on board, thanks to the level sensing available on all sampling arms, we know exactly what is the amount of liquid in each position. And on this slide, we can also see that we are also providing ready to use reagents for a really huge list of parameters. Alkali, hardness, ammonia, NO2, NO3, TON, fluoride, chloride, silica, sulfate, chromium. And now we are also going to add calcium, magnesium, because one of the trends is also to run calcium and magnesium to be able to determine calcium hardness and magnesium hardness. And this is the really important feature we have. So with the reusable cuvettes, because we have a reaction plate incubated at 37 Celsius degrees, so temperature is stable at the same for all the reactions. We have reusable cuvettes for very low cost of ownership, parallel reactions for high throughput of multiple tests, and when washing the cuvettes, the quality of the cuvette is automatically checked and verified at the end of each wash. Really, one of the big points, because when using reusable cuvettes, is that the efficiency of our washing station can really minimize the carryover effect from test to test. We have a lot of labs working with decided to work with SmartChem, in this case SmartChem 600, because instead of spreading the different matrices between the different departments of the lab, drinking water, wastewater, they are collecting today all the samples in the same area and running all together, so wastewater, drinking water on the same unit. We have, as we already say, 2 arms for reagents, 1 arm for samples. On the reagents, we have integrated preheating system. Why? Because the reagent compartment is refrigerated to prevent any thermal shock of the solution. So to pass from around 10 Celsius degrees, 10 Celsius, to be incubated in a cuvette that is at 37, we used to pre-warm the reagent in the needle. And also in this case, we can see that thanks to the level sensing we have on samples arm and reagents arms, only 1 millimeter of each needle will be in touch with the solutions. So this will make us able to properly clean, wash the needle inside and outside, and to minimize the carryover. So the matrix effect between the different reagents and the different sample matrices. When speaking about consolidation, one big plus is that we can also keep our discrete analyzers with add-on modules, where we can see here on the left the add-on module to run NO3 testing, so NOx, TON testing as per cadmium reduction. Of course, on all our discrete analyzers, TON, NOx can be also determined via hydrazine reduction and via vanadium chloride. And moreover, we can also optimize and automatize electrochemical testing on the same platform, because we also have an add-on module where we can determine pH, conductivity, and ORP. The big plus concerning the NO3 module is that operators are not anymore in the need of manual handling the cadmium coil, because also the activation and regeneration procedure is totally software driven. So means that following the driven procedure available in the software, the operators only need to load the solution on board, and the instrument will take care of dispensing them inside the column to perform the wash and the activation. The SmartCam Pro is really designed for better user experience, because it's very versatile and easy to use software with very intuitive graphic interface, different access for different skill, and we will see more in detail after. We can, as we say, manage complex activities with easy and automate lab schedule startup and shutdown. We can be fully compliant with EPA. We will see why. We have a full automation concerning the analytical routine, and concerning also the control of the results, because it is really important to consider that by automating, by defining all the proper settings for each method, we can automate not only the analytical routine, but also the result evaluation. And easy for self-service and support, because we have also built-in recommended preventive maintenance with all the checkpoints, and also comprehensive diagnostic that allow us and the customer to control any individual hardware or part of the instrument, mechanical, hydraulic, and electronic. We spoke many times in the previous slides about the true walk-away experience that we can do by using the SmartCam. And what are the four main factors that allow us to speak about a true walk-away experience? Because different from other instruments available in the market, thanks to reusable cuvettes, the instrument is not requiring any cuvette loading from the operator, because cuvette will be washed and reused. We have the possibility to load multiple caps for standard and QCs. That will guarantee us to have enough liquid also for QCs to cover very, very long routines. We have the possibility to load multiple bottles for reagents and diluents in the reagent compartment. And the instrument will directly manage to go using the next bottle when the one in use will be empty. And moreover, when a new analytical routine is ready to start, the software will automatically check, thanks to the automatic inventory management, if the remaining volume on board for all the solutions is enough to cover the amount of the required test. If not, the software will pop up a reagent level status where the operator can see what are the reagents that need to be refilled to be able to have enough liquid to cover the routine. So it means that when starting the analytical routine, you can be 100% confident that the instrument is able to complete all the testings without any human intervention. And moreover, we can also automatize the startup and the shutdown procedures. So what does it mean? We can program the automatic startup before our arrival in the lab. So when we will arrive, the instrument is ready to start analysis. We are not, we don't need to wait any starting time, because everything has been already done, and we can also program automatic shutdown procedures. For those parameters that are not sensitive to onboard timing, we can also, in the automatic startup program, to run automatically calibrations and QCs to check if the calibration are okay or not. What about data reliability? Today, we could be prone to human errors while running the testing. We already saw that with SmartCam, we can fully automatize the analytical process, but doing the proper setting in the software, we can also have a fully automated enhanced check for the calibration. Why? Because we can determine automatic management, define automatic management of the RBL, which is the reagent baseline. So with the RBL, we can determine what is the absorbance of the reagents in the total reaction volume. And this value can be removed from the final color we will read from in the cuvette at the end of the incubation. Moreover, we can, as we can see in the first two options for the RBL, have the automatic rerun in case of reagent changes, because we spoke about multiple reagent bottles, but the color of the reagent could be different. One typical example is the NO2 reagent that could become from transparent to dark pink over time because light sensitive. And when it is too colored, it is losing sensitivity. And in any case, the bottle in use could be bit colored while the brand new bottle is fully transparent. And automatically, when the in-use bottle will finish, the instrument are in the need to swap to the new one, the instrument will automatically schedule run the RBL. Also, RBL expiration, because we can define the stability, because the RBL, the baseline, is also related to the mobility of the reagent. So how often the reagent is changing color over time, we can define the stability and ask the system at the end of the stability to automatically rerun. So everything is automated. And we can also check the minimum and maximum value and define when the color of our reagent is still acceptable to consider reagent as working reagent. When running the calibration, we can control the minimum acceptable R-square. Moreover, we can control for linear regression models the minimum and maximum slope, because the R-square is an index for us to check the accuracy and reliability of the instrument in performing the automatic dilution for the different calibration points and to see the regression of those points. But the standard could be overestimated or underestimated. So the R-square is one index, but cannot guarantee us the goodness, the quality of our calibration. By automatically controlling the min and max slope for the calibration and or the minimum and maximum absorbance value for each calibration point, we can be also 100% confident concerning quality also for the correct preparation and value of the standard in use. And moreover, for each calibration point, we can run multiple replicates, and the software allows us to also check the CV percentage. So while performing the calibration, we can also ask the system to replicate multiple times each calibration point, and we can specify the coefficient of variation between those replicates to check the repeatability of the instrument and performing the different dilutions in the calibration. We can also fully automate the management of the duplicates, because with SmartCam we can automate the scheduling of the duplicate during analysis. We can define when, after how many samples, the duplicate need to be managed. We can define the maximum RPT percentage we can accept, and we can manage, we will see better in detail, the on-fail behavior. We can manage automatically also spike and the duplicate of the spike. Those two controls are very important, because on normal QCs, we are just preparing on type 2 water, adding the molecules of interest for the analyte and run it. But with the duplicate and spike, we can also check the repeatability and the accuracy of the instrument on the real sample matrices. So we can check the repeatability by running the duplicates and monitoring the RPD percentage. We can automate the spike to check the accuracy of the instrument in performing the spiking. And we can automatically control the recovery percentage. And moreover, running the duplicate of the spike, we can check the repeatability of the instrument in performing two subsequent spikings. And we can define multiple spikes for each method. So low, medium, high spike. Concerning QCs, we can define all the main info. So the target value, standard deviation, software will automatically calculate minimum and maximum value, the acceptance range, or we can define the acceptance range and the software will automatically calculate the target value and the standard deviation. A QC can also be scheduled as per our need, when initial means before running samples, final at the end of the analytical routine, and dynamic with frequency means after how many samples we want to have the automatic schedule of the QC. Now we saw on the R squared the corrective action, on the duplicate of the spike on QC. And what does it mean? If one of our result will not match the defined acceptance criteria in the software, we can decide on fail one of the 5 available actions. For example, rerun the control. Also on rerun fail, we can decide what to do. For example, stop only this method if there is an issue, and go ahead completing the routine with all other analytes scheduled for all our samples. Otherwise, if the rerun will pass, you can just rerun the previous sample block. In this way, we can be 100% sure that all our sample results are in between of 2 QC blocks successfully passed. And what does it mean, considering the fully automated enhanced calibration check and fully automated enhanced management for QC duplicate and the spikes, that if we have no flag assigned to a test, means that the results are matching our evaluation criteria. So it means that also concerning result evaluation, we are not any more prone to any human interpretation or human error, because for each test we will do, the instrument will apply exactly the same rules and will check if the results are within our defined settings for each method. Very important is that we can define and we can say that we are fully compliant with the EPA running mode, because we already saw that we can control the R square, we can define the duplicates, how to make the duplicate, and we can check the RPD percentage with corrective actions. We can automatize spike and the duplicate of the spike with corrective actions. We can define an attended number of QCs, and for each QC, as we can see from this slide, we can also, based on NILAC EPA protocol, which kind of control we need for each control. For example, if we are going to define ECV, automatically the software will only schedule those controls before running samples, because it's the initial calibration verification. While if defining as CCV or CCB, will be only managed in dynamics, so in between samples and at the end of the analytical routine. And moreover, we have possibility to run our analytical routine based on the NELAC EPA scheduling mode. So it means we are going to manage the scheduling in strictly batch, 1 parameter per time, waiting to see the result if there are the needs to manage post-dilutions. If so, manage post-dilution rerun testing for out-of-range results, and only when all testings have been completed for a specific parameter analyte, software will start running the next analyte on the required samples. We can also automate the management for out-of-range results, not only concerning those results that are out of range in terms of concentration, where we can define post-dilution or reflex testing. Concerning rerun post-dilution, on our SmartCamps have been developed a new protocol that is able to move back the out-of-range result in just one shot, just by running only one single post-dilution. Because by comparing the absorbance of the sample and the absorbance of the calibration, the last calibration point, we know how many dilution we need to perform on the sample to move it more or less in the middle of the range for the calibration of interest. While with the reflex testing, we can also decide, instead of running post-dilution, to rerun the sample as it is with another different calibration method. Moreover, we can also monitor and the blank of our samples. We already saw in the previous slide that we can manage true sample blanking in the cuvette. And we can determine the threshold value for us or for the sample blank, and if the blank of our sample will exceed the value set for each method, we can also define post dilutions to dilute the sample, consequently to dilute the color of the sample itself. One typical case for customer applying this is when they are in the need to run, for example, pollution testing on soils extracts, or managing wastewaters, where those matrices could be very, very dark sometimes, and the color of the sample itself can affect the colorimetric determination. This is why we implemented this feature in our software platform. Very important for us is the fully compliance with 21 CFR 11, because we can guarantee the electronic records and signature, the data integrity and security, and moreover, the full system covered by integrated backup and recovery procedures. How we can meet those requirements that for labs are really important? So we can guarantee the access to the platform based on username and password, so unique access for each account, for each user in the software. We can also define multiple level concerning user profiles. So we may have admin user, the application specialist or lab man, or let me say the technical manager of the lab, plus just operators. And we can guarantee who can access in editing and viewing, or only in view mode, or not access to not have access at all to a software. And moreover, we have the full user login history, as we can see in this slide. So we have the activity performed by each user, and when selecting a row, a line in the log table, we can obtain further information. So what changes have been done by the operator for a specific method, for example. Very important is the possibility to cover and the needs of the lab concerning full access view and operator view. We implemented in the software the possibility to have, with the advanced view, full access to the menu, to all our software areas, and we can having the grant to pass from one view to the other, or we can just create operator profiles that can only access the system as operator, and they will only be able to run testing. So there is no chance for those operators to access different software areas. They can only enter in the routine menu and just running samples, running calibration, and evaluate the results. As we already spoke, but now a bit more in detail, we can speak about really versatile platform, because we can run multiple parameters per sample. We can run multiple matrices in the same routine, and we can also define multiple work plans per run. For example, we could divide our analytical routine by matrix, or if we are a commercial lab, we could define different work plan based on customers. So group already all our samples per customer without the need to search or let them in a unique sampling results table. And very important is that we have a fully flexible import from LIMS. We can set the import in two different ways. The standard way, that is with CSV. So the LIMS will generate the file we can import, the working routine, and also with the ASTM protocol. So the American Society for Testing and Materials, it means a query mode. What does it mean? For each sample, we can send a query to the LIMS asking what are the parameters we need to run for this specific sample. Again, the sample barcode, the sample compartment is equipped with barcode readers, so we have positive recognition of the samples. And so our operators, they don't need to load each sample in a specific position, but they can load the samples as they want in the rack. The system will scan, will determine from the barcode label which sample is in which position. When importing from the LIMS, the working table is automatically created. So having the instrument equipped with barcode readers, we can also skip any human error in concerning liquid positioning on board. We have a really versatile also result page and report feature. Really important for accreditation purposes that we have not only full audit trail concerning what have been done by each operator, but we can also see and recall info concerning method configuration when selecting a specific result. This is the full list of features available for us. And we can see we have method configuration. So by selecting view method, we can review all method settings used to obtain this result, to run this test. By selecting view calibration, we can see what is the used calibration, what calibration have been used to obtain the selected test, the selected result. And moreover, when selecting a test, of course, the test is related to a specific parameter, analyte, and we can also, through the view QC result, open the QC charts to see also for the method of interest the QC charts directly without any need to navigate different areas of the software. And of course, we can exclude the result from the LIMS or generate the LIMS, the CSV file for the LIMS to upload your results. Moreover, we can also perform post-elaboration for a calibration. We can recalculate the results by editing specifically the calibration of interest, or we can also, when we are in the view calibration, decide to recalculate our result using a different calibration we have in the archive for the method of interest. Calibration results view. This is really appreciated by a lot of customers because it's very comprehensive. We have all the information we need concerning the reagent baseline and the calibration curve. We can see everything is coded by color. Each color in the grid is matching the color we have in the screen. We can review at any time the reaction of each point or compare the reaction of all the replicates in the same graph. And moreover, we can also compare the current calibration. You can see the blue line with any previous calibration we have in the archive. Moreover, we can open the archive and select and set as active any previous calibration. Moreover, when selecting a single calibration point through the show history feature, we can see the trend over time for the specific point, for the point of interest. Again, to help labs also during the accreditation, we have also built-in QC charts, both Levi-Jennings and Uden charts, where we can not only see the trend over time for a QC, but in the same window for the same method, we can also compare two QCs, for example, high QC and low QC, because we can also monitor the trend of both and see if, in case of an issue with the QC for the low QC, if the high QC is okay and the low QC not, we can further address the low QC, checking how we are preparing the QC and so on. So we can be part also of the evaluation process through the thanks to the information we can obtain from the SmartChem software. The last but not the least, very important, is the integrated troubleshooting multimedia library, because there is with need help feature in the software, proceed to open contest awareness library, tutorials media library, where the software will list procedures, video tutorials already matching that contest. For example, if we are in the calibration, we will click on need help, the software will show us all the procedures and video tutorials related to the calibration results. So how we can edit the calibration, explanation of the mask. And moreover, we have also integrated guide, so software manual, also in this case that will open directly matching the contest where we are in the software. So, and we saw a full panoramic of how KPM, in this case, MS, the wet chemistry brand of KPM, can help labs to scale wet chemistry, to streamline the process, and to really approach the consolidation of the lab. So now we can open the Q&A session. And I would like also to invite you, and we will be very happy to see you all in person in Analytica 2026. And in any case, if you want to have more in-depth information about our products and about KPM, please visit our website that you can see here, www.kpmanalytics.com. So there are two questions. We currently have 3 QCs that we have to prepare individual from our instrument. It would be great if we could just load the stock solution, tell the system to make each standard from that. The instrument can automatically. Yes, this is a feature we implemented already in the software. So possibility, instead of automatically manually preparing the QCs, to have QCs automatically prepared by the system starting from a standard. Because we can define the name of the liquid and we can define the dilution we want to apply. So we can ask the system to automatically prepare a QC starting from a standard. Way to study that the system prepare the QC from a stock. Okay. This can be standard method for examination. Yes, of course, all the methods we can run, we have the panel for methods compliant with standard methods requirement, of course. So in each application note, we are reporting the regulations. So you can double check if the method is compliant with the specific regulation or not. And in any case, we can automate any manual testing. So what does it mean? Also, if today you are running a specific manual colorimetric, spectrophotometric testing, we can, as we are doing today with a lot of customers, working together by checking the manual method they are applying in the lab and see how we can automate. And of course, we have been able to automate a lot of parameters that were already not in our panel, but performed by the customers with manual methods. Moreover, I would like to show you, speak with you also an important step that we are doing. We are also automating. Give me just 1 second. Let me just stop sharing the screen for 1 second. I would like to show you one important thing that is part. This one. Let me know if you can see my screen. Can you see my screen?
Yes.
So we are also working with the customer in automating manual kits today available in the market. This is one of the most success cases. So possibility to automate the monochloramine testing from the manual kit today available in the market. In this case, we can really see from euros to cents. Why? Because with the actual manual kit, it is possible to run just one sample with one reagent powder available, while automating the kit on SmartChem with one reagent powder, we have been able to run up to 50 samples. It means that a lab can reduce 4 times the expenses, the cost of the kit. So still using the same kit, but by automating on SmartChem, they are saving a lot of money. Another question, to increase the sample capacity of the 600 sample. Yes, this is something we are quite ready to announce. There is a dedicated session because we are working in really perform a huge increasing of sample capacity on the 600. And so yes, more, really more than 200. There is another query. Yes, the question is how the cadmium coil work. Let me go back on the other presentation. Just 1 sec for me to stop sharing and going back to my previous presentation. And the slide is this one. Okay. This one, perfect. So we have a port where the instrument, the needle, will take sample plus buffer that could be immediate. So if you're running ISO standard methods, or could be ammonium chloride if you're running EPA methods, then there is a peristaltic pump that will move the sample plus the buffer in the coil and will flush the sample inside the coil for a specific number of cycles to guarantee the correct reduction yield. Then the reduced sample is moved back to the entry port, and the sample will take only the amount needed to perform the colorimetric testing in cuvette. So in this case, we can consider the NO3 cadmium reduction module as a pretreatment step of the sample, because we are pretreating the sample with the cadmium module to reduce NO3 to NO2, and then at the end, we will take an aliquot of the sample to measure, determine the total amount of NO3 in the sample. And now, speaking about this, it is, I would like also to inform you all that on SmartChem, we can also define mathematically calculated tests. What does it mean? We can define formulas to mathematically calculate results from real testing we are performing with the instrument. And one typical case is a formula to determine the amount of NO3 in my sample, because passing through hydrazine, vanadium chloride, or cadmium coil, we are measuring the total amount of NO2 in the sample. So original NO2 plus NO3 reduced to NO2. Then we can run NO2. We can define a formula where NO3 is the difference by TON NOx minus NO2. So we can directly assign the calculated, mathematically calculated parameter to a test, and automatically the instrument will run all the methods involved in the formula. So we can see all the result of each parameter we have in the formula, plus the mathematically calculated result. I think, yes, the last, can the sample will be separated by hazardous and non-hazardous reagent? Yes, this is one of the main plus when we were speaking about cost saving, because we said that already that instrument is, all the SmartChem are only generating liquid waste, and moreover, we can separate, thanks to dedicated waste line, separate normal standard disposal, so wash waste, from the reaction waste that are in the need to be collected and treated, and are only around 30%, 35% of the waste generated is a reaction waste. The rest is normal wash waste. So this was the last question in the Q&A area. Please do not hesitate. No, there is another one. We currently now just arrived. We have to see the. No, this is the same exactly already sent before. We already provide an answer. Yes, we can prepare QCs from stock solutions. So we are not anymore in need to prepare the specific QC, but you can ask the system to prepare QCs from a stock solution, from a second source standard. There is a question, but without recalculating. Without recalculating is referred to which question or to which answer I was providing? Yes, of course, we are not taking into account when preparing from the stock the dilution. Otherwise, we will go back to the original value, the initial value of the standard. If we are diluting, then multiplying the obtained result by the dilution. Thank you for the question and the clarification. So 2 minutes to end this session. There is another one. Could talk briefly about user serviceability of the instrument. Yes, what the instrument need to do in terms of service, because we were already managing this. Where it is, one sec, which slide? Okay, 100, building maintenance. This one. So what are the operations in charge for the operators in terms of maintenance? Is only to clean the needles one time per week or every 2 weeks. But in any case, there is a table already, a maintenance scheduling inside the software that will, let me say, remember you what are the maintenance that need to be done. In any case, is to clean the needle, when and if needed to replace cuvettes, because cuvettes can be replaced as a single cuvette, and you don't need to replace a full set of cuvettes, but individually. And then it depends on the also agreement between the lab and our local representative, because we have some labs having internal maintenance service engineers that we are training, and they will take care about the full maintenance and service on the unit. So replacing the lamp when needed, replacing cuvettes, and washing the inlet tanks, and cleaning tubings, performing the wash of the system. So it depends also on the level of maintenance that the lab would like to address to the operators. No, this is a plus on the SmartChem series. So SmartChem 210, 450, and 600. By default, on the standard configuration, there are no peristaltic pumps. The only peristaltic pumps available are those, correct? We are available on the 2 optional modules. And in this case, it's very easy, because we just need to unlock the pump, remove the head, remove the whole tubing, put the new one, and put the head of the pump back and closing the arch to have the pressure back on the tube. And that's all. So we arrived at the end of the webinar session. You can see that there are no further questions. So thank you again, and please remember to visit us in Next Analytica. We'll be very happy to meet you and go through where you can see passing from the screen to reality. So having possibility to touch, interact also with us with the instruments. And please visit also our website, www.kpmanalytics.com. Thank you again. Thank you again, you all, for attending this webinar.